Yeah, I'm just going to start here. So welcome everybody. Good afternoon or good morning from wherever you're joining us today. My name is Markus Kleinfärcher. I will be your host today for this electronic pulse session. For those of you who don't know what electronic pulse is, it's basically a framework where we try to present startup success stories from startups to startups and students and everybody who is interested in the realms of the startup ecosystem in Austria and beyond. So we are very happy today to have TriLite Technologies here with Adarsh. I got it here. Prasad. Yeah, you're a senior engineer from TriLite Tech, and in joining us from America today, actually the CTO and co-founder of TriLite Technologies, Jörg Reitterer. So we are super excited for you guys to be here. Thank you for showing up. Thank you for supporting the startup community and giving a word about your success story. I think there is somebody still going to join us. Okay, but I'm going to give the word to you guys. So stage is yours. Thank you for being here. And yeah, let's do it.
All right. Thank you very much. Can you see my screen now? Is everything working correctly?
Yes.
Great. Thanks for the kind introduction, and thanks for hosting this exciting event today. So I'm Jörg. I'm co-founder and CTO at TriLite Technologies, and we like to see ourselves as a kind of 10-year-old startup. And in this talk, we would like to present a bit of our journey coming from TU Wien research to becoming basically a global tech leader in the field of augmented reality. And as Markus was mentioning, I'm dialing in from Silicon Valley right now, and this is why we decided to split the presentation into two parts. Adarsh will be on site at the Infineon Innovation Hub. He also has brought some of our samples with him, so in case there are more people joining on site, you can also see some of the samples at the sites there. All right, so let me start with our company vision. So at TriLite here, we are building the world's smallest projection display for augmented reality applications. And our vision is that everyone enjoys augmented vision as lightweight as the eyewear of today. And this statement contains a couple of very important things. So first of all, we are focusing first and foremost on laser beam scanners for augmented reality applications. So, we can do many different things with those so-called laser beam scanners, and Adarsh will explain in the technical part how the whole system works. But we are focusing exclusively on augmented reality displays and using those laser beam scanners to project images into your eye, basically. And when we talk about our applications, we are focusing on consumer products. And this also means that all technical requirements in terms of size, weight, brightness, image quality, power consumption, and so on need to meet those requirements. And they are very challenging, to be very honest. And Adarsh will also give you some examples of some augmented reality devices of today. They are still quite big and bulky. And as you can see in this image here, this is basically the vision that you have a pair of glasses that looks like a regular pair of glasses nowadays, just with this added functionality of augmented vision. And last but not least, when we talk about consumer products, the whole manufacturing aspect is also very critical to us. So both in terms of designing components of the system and also in terms of the assembly processes that we need to set up in order to support large volume production for our products. So let me briefly explain a bit of the background of our company. So we founded the company over 10 years ago in 2011. We are headquartered in Vienna, actually very close to the Infineon Innovation Hub. And we have a very long track record of building laser beam scanning systems. And we will also explain a bit later some of those stages of those developments and how the whole products that we have developed have evolved over time. And obviously, when we develop such products, IP protection is very critical. So this also means that we need to have a certain patent portfolio protecting some of the key areas of those systems. Right now, we are a team of 30 people, and building those type of devices is a very interdisciplinary thing. So we need to have a very unique skill sets in our team in areas like optics, photonics, in MEMS, in electronics. We also put a very big emphasis on algorithms and software. And last but not least, also mechanics are very important, including thermal management, etc., when we build those ultra compact devices. A bit of a shameless plug here. So we are hiring right now. We have many open positions. So in case you're interested, feel free to check out our website. So we are still in the process of growing and ramping up the team to support the development of our products. So also a bit of a history in terms of our funding. So when we started the company 10 years ago, in the very beginning, we were lucky to receive some public funding also from the Austrian Research Promotion Agency, FFG, also some funding from the European Commission, also some funding from business angels. And nowadays, basically for scaling up the team and also for bringing our products to production, we are also backed by some deep tech venture capital investors. And on the right hand side, you can see some example. This is the most recent funding round that we closed last year in October, where we raised money exactly for scaling up team and bringing up the production capacity, basically. Here you can see our management team. We have a very experienced team here, starting with Peter, who is our CEO. He has a very strong background, both in the corporate world and also in the startup world, also working in augmented reality field. Myself as the CTO, we have Stephanie, who is an expert in finance and controlling. We have Dietmar with a very long background coming from AMS and building large volume consumer and also automotive products there. And last but not least, we have Mike, who is our VP sales, and he's located actually in the United States and responsible for sales activities here. Talking about our investors, we have investors like Hermann Hauser, for example, who you might know. He's one of the co-founders of ARM. And then we have, as mentioned before, some venture capital investors based here in Austria. Actually, we have Apex Ventures, we have i5 Invest, and also BNC as some of our investors, also from the most recent investment round. As mentioned before, we are headquartered here in Vienna, in the 4th district. We also have one of our technical leads located in London. And since many of our clients and also suppliers are located on the West Coast in the United States and also in Asia, we are also in the process of expanding towards the United States. Right now, we have the VP sales already located here, but we also plan to expand the team here in the United States, and also looking on the other side of the world towards China, Korea, and Asia in general. We also want to expand in that area because there's also key customers and suppliers located in that region. So here you can see now a quick technical timeline of our developments that we've been doing in the last 10 years. And in the process of developing all of those systems, we actually broke a couple of world records when it comes to building the smallest LBS systems. And the first major milestone for us was in 2013, where we had our first laser beam scanner with a 1D scanning mirror back then. So the mirror could rotate about one axis only. It was only 3 red laser diodes at that time, and it also the packaging was not comparable to what we have today. And over time, those type of laser beam scanners evolved. We then moved on to using red, green, and blue lasers. We improved a lot in terms of also electronics and software over time. And then we went through a couple of generations of what we call those Trixels, which is the name of our laser beam scanning product. So we had the Trixel 1, 2, and now this is the most important one right now, the Trixel 3. And this is also where Adash has some samples with him today. And this is completely redesigned from the ground up to be optimized for augmented reality applications and to be optimized for mass production. So this is for us a very important milestone, and we are in the process of bringing this product to production with the goal to ramp up next year. And yeah, for us, this is very exciting. And this basically concludes my part, my section of the presentation. So are there any questions on the founding, funding history of TriLite, etc., from the audience?
If there are no questions, you can also put them into the chat later, or yeah, so we can have them answered at the end of our presentation. So for Q&A afterwards, feel free if you have any more questions to put them in the chat or ask them personally.
Okay, then thank you very much. And then I would now like to hand over to Adash. So I'm going to stop sharing here.
Okay, good. Thank you, Jörg, for the introduction to TriLite as a company. So I'm an optical engineer working at TriLite, and I would try to go over the technical aspects associated with such devices as we are making. But before we go into anything, I would like to clarify the difference between very commonly interchangeably used terms VR, AR, and MR. So what are these? So VR is basically having a completely digital experience, whereas AR, as you can see in this photo, is having a digital world or digital elements overlaid on physical elements. So you see an actual physical train, and you have like digital information like date, time, whatever, battery, message. So this is augmented reality. Going a step further, we get something called mixed reality, where we have digital elements again overlaid over physical elements. But what separates it from AR is that the physical elements and the digital elements can interact with each other. So that makes it even more immersive. So together, AR and MR comes in the family of extended reality. And what our company is trying to do is to enable the AR realm of this technology. Going a step further, we all know recently this has been so much in the news, and a lot of the big firms, they are chasing this the goal of realizing augmented and mixed realities. And you can often hear big names such as Microsoft, Google, Apple, Amazon, and Facebook, formerly Facebook, now Meta. And it even changed its name, which kind of hints towards the importance of the upcoming augmented and mixed reality world. So I'm not going to go into details of all these announcements, but you can find this out online, what these companies are trying to pursue. What is currently happening is that there are devices which enable augmented reality already in the market, but they somehow are not so widely adopted because they don't meet the key expectations from the consumer. So you can see here like several photos, and you see the word bulky written, and I mean, you see like you can't wear any of these devices and go walk on the street. So earlier I was talking, and yeah, I got to know that I was talking to Marcus, and someone was wearing this on the street, and it looked really out of the world. So I even have a sample of what you see on the bottom left. So it's called Microsoft HoloLens, and I'll quickly wear it to give the presentation, and you can see how bad it looks. So, I mean, this is a very bulky sample. I don't know if you can see it, but this is one of the major challenges with the current devices. So one has to make the footprint of these devices really small. And on top of it, like such bulky devices have low quality visuals, and the visibility, for example, in the outdoors is super bad. The transparency of these glasses is super bad. You cannot see outside so well as you would see through normal glasses. And the fitting process, as you can see, this is almost the fitting process is like that of a bike helmet. So you don't want to, if you have a wearable which you want to wear for the entire day, you don't want to have such a thing. You want to have a pair of glasses, you lift it up and you wear it. So that's what is the eventual goal. And that's where our company is headed. And that's where the consumer requirements are. So the key requirements for such eyewear from the end user perspective is that it should fit well, it should be stylish and fashionable. One should be able to wear it continuously, whether you are inside the room or outside. You don't have to like change settings or anything. You should have a good image quality. Like if you want like crisp image, you want immersive experience, like you want to have a high field of view and so on. And most importantly, you don't want it to die like your iPhone. Like every day you have to charge the iPhone. You want a low power consuming device. And so what is shown here in the slide, you can see in the light blue color is the perspective of an end user. You want the perfect fit, but that translates to small and lightweight when you think in terms of the OEMs. So basically that translates to a technical requirement, and I would go through each of these key requirements one by one. So the first requirement is that it should be a perfect fit. And I showed you several devices which are really bulky, and you put it on your head, and you cannot walk with them. So some of these devices are made from panel-based displays. So you have like micro LED and LCOS-based displays. So micro LED is self-emissive, whereas an LCOS display or a DMD-based display is a reflective display. And you see that in all of these cases, whatever is emitted out or is reflected needs a lot of optical elements to combine. And that's why these devices get really bulky. So this is just about the source. Now the light goes into the waveguide, which is shown here on the right-hand side. For example, with this blue thin bar, and the light travels through it and then goes into the user's eye. But just the fact that there's so much of extra requirements on the optic size makes it really heavy, and it does it and it removes this the fitting element. You want it to fit perfectly, and it doesn't. So this is where laser beam scanners come into picture. So in laser beam scanners, you have like a light, so RGB laser module, for example, and you have a MEMS mirror. The light shoots out, the MEMS mirror kind of oscillates in 2D, and then with minimal amount of optics, you can couple light in. This is the general principle of a laser beam scanner. And this already reduces the size a lot. What we are at right now is what we call Trixel 3 laser beam scanner. So you can see how small compared to other devices. I mean, other schemes are not to scale, but you can see how small this is. And I do have some samples here. I do not know how I will show it, but for example, this here is a single, I don't know, can everyone see it? This is a light module from our company. It's called Trixel 3. So it's a third generation light module, and it basically fits on a finger. You can see this. So this fits the user requirement that it should be lightweight and it should fit perfectly. And it can be integrated into such an augmented reality eyewear. Moving forward, the user requires stylish glasses, and you want to have the light module or whatever the light source is, image source is, at different points in the glasses, and only if the source or the light module is small enough, you can put it at any desired spot. Otherwise, you're limited with you're not so flexible with putting the light source with respect to the display technology. Moreover, like there are other requirements such as it should fit it should meet face wrap and pantoscopic tilt, which is nothing but like tilting with respect to the vertical plane. Such requirements, to meet such requirements, you might have to design like completely new optical setups with other display technologies. But what LBS allows you is that you can just tilt this, or I don't know, put it in the required way, and that enables like various integration geometries, and that makes it very versatile laser beam scanners. Yep.
Sorry to interrupt. Just to understand better, so when you say that with LCD or OLED displays, you have to integrate some other optics in order to accommodate the, for example, the tilt on the vertical plane and the bow on the horizontal plane. You mean that you need more either mirrors or optics in order to bend these waves?
That's one way to think of it. I mean, you need the optics, for example, to, these micro LEDs or so on. These are like point emitters, and there's an array of them, and the way they emit light, you don't see the you do not gather all the energy. So you have to kind of collimate optics, and then you have to like have the right field of view, and for all that you need like lots of optical elements.
And this changes from tilt to tilt, from pair to pair.
Exactly. Okay. For different tilt, you might have to change the optics because the light is not coming out the right way. Whereas in our case, I will come to this later on, how it integrates with, for example, a waveguide-based display. You basically take this and you just put it with your hand against the waveguide, and it should work. It's that easy without any external optics. So yeah, so to enable stylish and cool to wear glasses, you need to have something which is versatile, which enables various integration geometries, and laser beam scanners such as ours enables that. The third requirement, and many of you who come from Austria probably can appreciate this quite well. So you want, like, for example, if you're skiing, you want, I know in Austria everyone skis, you want like glasses with, let's say, AR displays to be sufficiently bright, because outside it's supposed to be super bright. Or if you walk in the sunlight, you should be able to see what's being displayed on your glasses. And compared to other technologies like LCOS and MLEDs, LBS is like a factor 10 better when it comes to brightness. And also with respect to the contrast, LBS offers a much higher contrast as compared to LCOS and MLED technology. So this makes it really versatile in terms of the conditions under which you can use. Technically, it translates to having a high brightness and a high contrast. Another requirement is that any kind of display on your computer, you want really nice, colorful images. But that's possible only when you can select like a large number of combinations of red, green, and blue colors, right? They together form the white, and changing the red, blue, and green components, you can achieve different colors. So this is what is called a color gamut. So you can see on the left-hand side a plot where you see these triangles of different colors. They basically enclose several XY points, okay? These XY points are equivalent to the fraction of each color. So let's assume red and green. And the third one can be extracted if you know the value of this X and Y, for example. So the point is that the larger the area of this triangle, larger is the combination of XY values that you can obtain, right? This means larger is the number of combinations, RGB combinations that you can obtain. And you can see that the green one and the black one, black dashed lines, they show the color gamut that's obtained from MLEDs and LCOS. And the red one shows you LBS. So you can see that the LBS offers a much higher range of colors. On the other hand, on the right hand side, you see that on the top, you see a distorted image. So this image is supposed to be a rectangle, but somehow deformed. And what LBS can do, so in our case, we have advanced calibration algorithms, which can remove these distortions on the fly. So, you don't need extra relay optics, or I don't know, some other optical elements or very sophisticated optics to compensate for these distortions. And I'll come to this point later on. It has many other advantages, but LBS in general allows for high color range and undistorted images quite easily. And this kind of is one of the big requirements for the consumer, and that's met by LBS. Another very important requirement is that when you wear such augmented reality glasses, you want to have a good experience. So you want to have a high field of view, for example. You don't want to squint into a very narrow angular area and try to look at the image or try to look at the information. You want to have a very high field of view, and LBS kind of offers this high field of view. Since the projection of optics is eliminated and the field of view is limited only by the combiner optics. Another important thing is you want high refresh rates, and through our painting algorithm, and also because of the high speed MEMS, it's possible to achieve high refresh rate. So that's very important. And another important thing is the perceived latency by the user. So from the time the information comes in to the time the user perceives it, you want to have as less delay as possible, right? And LBS kind of provides all of these as well. One last but really very important requirement when it comes to having a device is having infinite charge. You cannot have a device which runs forever. So basically what you want is to reduce the power consumption of all the elements which is in your device. And bigger devices or panel-based devices, they are really power hungry. They consume a lot of power, they get hot and so on. And electrical energy is converted into many other forms that's not desired. In our case, the laser diodes, which are the source of light in the laser beam scanner modules, they are very efficient in converting electrical energy to photons. And that makes it very energy efficient, basically. On top of it, instead of having large optical elements, we have a very small MEMS mirror, which, by the way, is provided to us by Infineon, and it's also very efficient when it comes to power consumption. So in totality, I will come to some figures later on, but I would like to say that LBS allows you ultra low power consumption, and this is very important when it comes to an eyewear, because whatever the source of power is should be on your glasses, for example, and it should be able to handle the power requirements of such devices. And LBS kind of fulfills it with very low footprint requirement.
What's a MEMS mirror?
Sorry?
What is a MEMS mirror?
So in our case, the picture is painted when the MEMS mirror reflects the light and kind of scans it. So the MEMS mirror is constantly oscillating, and the lasers, they pulse, and you want the correct lasers in correct combination to pulse at the right time.
Oh, so it's like a sort of like a CRT-TV, and it's doing it by line.
It's not doing line by line, so I'll come to that. But you can see here, for example, in this figure on the right, you see that this is, let's say, the path of the reflected beam, and the dots, the red and green dots, they kind of indicate the pulses. So if you pulse the right and the RGB lasers at the right time at the right place, while the MEMS mirror is oscillating or reflecting it at different angles, you can paint the image. That's the entire concept.
So this mirror moves in 2 dimensions?
Correct.
Okay.
This mirror moves in 2 dimensions. And it's that actually brings us to a key point, like where our technology kind of takes over other technology. But before I go into that, I would I explain to you what the key requirements of such devices are, right? But do the consumers really require these devices? You may ask, right? So I would like to just show you a very simple example. So like 10 years ago, I don't know, or even 5 years ago, the AirPods, the Apple AirPods, or these wireless earphones, they were not so much in the trend, and it looked really weird when someone would wear it. Where is the wire? And there was not, people were thinking that there won't be such a big demand. But look at this. So this data is taken from source. You can see on the side the reference. But you can see that there was a huge growth in the demand for these, let's call it wearables, just like you have wearables. So you can, the annual increase in the demand was roughly 53%. In case of head-mounted displays, which would require something like a laser beam scanner, what we are making, the projected growth rate is 60%. So we are right now at at the rise of this trend, and it's supposed to grow quite a lot. So the numbers that you see is basically the forecast in millions of units of such head-mounted displays that will be required or desired. And this view is not only held by like market analysts, but also by the leading partners or the leading companies in this optical systems field. So this is a graph from Laser Focus World, so like a popular magazine, and what it shows is on the y-axis, it's the volume of the device in cubic centimeters, and on the x-axis is the field of view that you can obtain, right? And I told you that there are several devices: LED, LCOS, panel-based displays, and LBS. So in the bottom, you can see the blue ones. So these are the old LED or LCOS-based displays. Here, the volume was huge, like 10 centimeter cubes, almost as big as a fist. And the field of view, the scaling with field of view is really bad. So the larger the field of view, the larger is the volume. Such classes are really not ideal for what we discussed earlier. In the consumers want it to be small and fit perfectly, and this is just the opposite. So people have already worked in this domain, and they have improved this technology, but still they are not in this comfortable sweet spot where you can incorporate such devices into smart wearables, for example. So the volume is still quite large, although they have a larger field of view. What's interesting is that for the same field of view as these improved LED LCOS displays, you have a form factor which is 1 centimeter cube in these LBS. And again, I would like to put it in front. You can see it on my fingers right now. This is what the form factor is. And this really allows you to integrate it efficiently and without any problems into consumer level devices. So I would go a bit further and try to explain to you what the secret sauce is in TriLite. So one of the key ingredients is that we have shifted the complexity from hardware to software. So I told you earlier that many of the problems are solved by using complicated, sophisticated optics, right? It makes the device really bulky. However, in our case, all these kind of corrections are handled by a software, the software which kind of runs on the device. And the computational overhead is really minimal. And what we do is, for example, I can show you on the right-hand side, just a small demo that you see here, green, red, and blue spots. They are at different points, right? And it can happen that your lasers are not aligned and you have different spots. What you would do optically is to put lens and other optical elements to combine these together into a single spot. But what we can do is we can shift all of this complexity to the software. And what happens, so we use machine learning based some calibration algorithms, some really advanced algorithms which allow you to combine the 3 colors effectively and obtain a nice superposition, which looks completely white in the bottom, you can see. So shifting this complexity from hardware to software really simplifies things when it comes to mass production. You can have smooth process flow, you can have larger alignment tolerances because you can correct for all of these in the software. And you can, hence, you will have like a higher assembly yield. Not only this, we also use a slightly advanced form of scanning. So on the left, what you see is a raster scan. So this is your question before. So this is a question, this is the technology which the old CRTs and TVs use, like they scan the picture from the top to the bottom. Whereas what we do is we scan like a sinusoidal pattern, and the entire frame is painted in one go. It slowly fills up the density of points, but you see the entire field together. And this allows you to get rid of several artifacts such as flickering, or I don't know, you see only half the picture and so on. So this is another key ingredient in our display engine. And you can see that in the first few milliseconds already the picture has been kind of painted, whereas the raster scan is only half done. So that's one very big advantage when it comes to our LBS. So going to the next slide, I would now switch to having a bit more focus on the manufacturing and what we are currently up to and long-term plans. So basically what we are aiming at is to reduce our consumers' time to market through our manufacturing service. So we are aiming mass manufacture. We are aiming towards mass manufacture. That's our eventual goal. We enable and qualify high volume contract manufacturers for this purpose for various so for the many different units which is inside this platform, and then with our technical know-how we can have like an integrated manufacturing flow. So with respect to this, Infineon comes into picture. So we have a very long relationship with Infineon. So we have teamed up with them to such that they provide us with 2D MEMS mirror. So the device which I was showing you today has Infineon mirrors inside it, and this mirror oscillates along two axes, and it's then integrated with, on the right, as you can see, the mirror by itself is not enough. You need to integrate it with the light source with correct optics and so on, such that you have a fully functional LBS. So that's how TriLite and Infineon team up to enable augmented reality solutions for the future. And just to quote some interesting parameters, as Jörg said, we were several times in the world records when it comes to laser beam scanners and smallest projection displays. So currently our Trixel 3 unit, it's less than a centimeter cube in size. I'm not going to show it again, but it's less than a centimeter cube in size, and the weight of such an LBS system, the Trixel 3 module as we call it, is less than 1.5 gram. So this is a huge improvement. Just for a reference, my glasses here, I weighed my glasses and they weigh like 40 grams. If you add a gram to it, doesn't change anything, right? So this is the advantage of having an LBS that is so small, which can be integrated into glasses. And you can see again in this picture, you want a pair of consumer glasses where this light engine is not so obtrusive. And you can see here, it appears as a normal pair of glasses, and that's our end goal. Another key figure is that we want, as I told you, we want high brightness, and just a number that we can get up to 3,000 nits brightness through when integrated with a waveguide. So again, a few key points. We are trying to provide display solutions which still remain stylish and can fulfill this dream of realizing augmented reality glasses, but with a small system, with a good visualization, and with easy system integration. And since because of our algorithms like real-time correction and low system latency, end-to-end system calibration, this makes all of this quite easy and possible. So Trixel 3 is optimized fully for high volume consumer AR applications. As I told you earlier, our goal, or the end goal, is mass manufacturing, and we want it to be produced in high volume. And our ultra compact RGB light module makes it possible. We have world-class, class-leading 2D MEMS mirror from Infineon, and we have our own technology of lasers and calibration algorithms, which make it quite suitable for combining it with, for example, waveguides without any relay optics, even. So I just would, at this point, like to show you these pair of glasses. I don't know if you can see it, but here is the light module. Okay. This is the light module on my finger. Okay, very difficult to get it on my finger. So it's very small, right? You can see it on the screen. And this module is now fit into So this is just a pair of mock-up classes, okay? So this module is fit into the temple of these classes, so it's already here, in here. Those who are here can see it. And you can see that these classes, they appear really normal, right? I mean, you can barely see the difference that I'm wearing like strange classes, right? So as I said, that's our eventual goal, and our LBS module being so small and having less dependency on correction optics and so on makes it very easily integrable into consumer grade classes. Some of the key figures when it comes to Trixel 3 is we have a volume of less than a centimeter cube. I told you the weight of such a system is less than 1.5 grams. The field of view diagonally right now is up to 30 degrees. We are aiming towards a resolution of XGA plus. The refresh rate, 90 Hertz. We have 2D mirror, as I said, from Infineon. Very productive collaboration. We have a maximum flux of 15 lumens, but this is at the LBS output. And as I said, this translates to, for example, with waveguides, it translates to a max output of 3000 nits. We have estimated the power consumption of such a device to, including all the electronics, driving electronics and so on, to be around 400 milliwatts. And it has a high color gamut and 10-bit color depth in each color. So altogether, it provides a very small, efficient solution for AR displays. And as I told you, our LBS has all components, the light module, the MEMS mirror, and everything, all in combination with the electronics, the driving electronics. So we enable kind of full stack display solution. So it's like you take our module, you plug in with your whatever display you want to use, waveguide, holographic element, and there you go. So we provide full stack solutions, and our path is very clear. We are moving towards mass production, and our system know-how helps us to design such ideal LBS, especially with respect to the size, weight, image quality, brightness, and power consumption. As I told you, very important requirements when it comes to such devices. And one of the key sources is that we have shifted the complexity from hardware to software, which enables it to be so small. And Trixel 3, this current generation of devices, it's designed from ground up for mass manufacturing. So it's set out to be the first 2D LBS for AR in production. With that, I would like to thank everyone for providing me an opportunity to talk about it. I hope I'm on time. Didn't exceed by too much.
Absolutely. Thank you very much. All right, great. Thanks to others. Thanks to Jörg for being with us here today. If there are any questions, please feel free to ask them now. Maybe unmute yourself, get your questions answered. Otherwise, I'm going to start with my first question here. Thanks, Sandra, for the applause. So my question is, what would be your expected time without recharging the system, given the form factor you have with a pair of glasses?
That would depend upon the size of the battery, right?
Yeah.
So I would say this probably is still TBD to be decided.
Yeah.
Depends on the battery that you would put in your system.
Yeah.
But just to give you a perspective, like your iPhone or whatever phone, Android phone, these have power batteries, which are like 5,000
milliampere hours.
Milliwatt hour.
Okay. Yeah.
And so you can run a device which needs 5,000 milliwatts for an hour.
Yeah.
And Trixel 3 has power requirement of around 400 milliwatts. So you can, with the same battery or this smart watch that I'm wearing, this has a battery of I don't know, 800.
So you would be equipped easily for a full day of working.
Yeah, we are trying to optimize it further, and it would heavily depend upon what kind of battery you want to put in your device.
But given the form factor, just having glasses, sometime you're going to run out of real estate to put more batteries on, and then it's going to be bulky and stuff. So I figured it might be interesting to know.
That's true. I think maybe Jörg can answer this question better. He might have more idea with respect to what we want to integrate into our system when it comes to battery.
Sorry, the question was about the battery life for the total system, right?
Yes,
Yeah.
that's correct.
Yeah. So as Adash was saying, it depends a lot on the exact use case. So it's also a big difference if you use it in a monocular setup where you have just one laser beam scanner for one eye, or you have a more immersive experience with two laser beam scanners and you have two displays, one for each of your eyes. But in the end, when it comes to the end consumer requirements, the battery life is very important. So for our clients, this is also very, very crucial. So we are still aiming to bring the power consumption down to lower levels even. And also the numbers that we mentioned before, this is for the max brightness, right? So this is for the max luminance you get out of the laser beam scanner. So on average, if you, let's say you're indoors, you will not need the max brightness. So power consumption also reduces accordingly. So it will be kind of an average between being outside, being inside. So in total, we anticipate it will be lasting with the type of content you consume for at least a day, let's say. And it will also probably not be on all of the time. If you look at a smartwatch, it's also not displaying image information all day long, but only when you look at it, for example. So for AR devices, depending on the exact use case, the number of on time hours per day, for example, will also be given a bit by the application.
Okay, great. Very much. We got a question here.
Another question related to, as a segue from battery life, but more towards use cases. At the beginning of the presentation, you blamed Microsoft lenses for being such a bulky device. And
it's an awesome device. It's just too big.
I agree with that, but it contains the battery and also a processing unit which gives you content. And this is my question here. So far, we've talked about the MEMS mirror, the amazing. You've made you made an amazing lesson into optics and how the laser would work better than the LEDs. But my question is, does this device also contain the content manager, what the end users end up seeing, or does it contain the communication tools to connect to a device that provides the content, such as a phone through Bluetooth or Wi-Fi?
Yeah, so to the first part of your question, it would contain the manager, or let's say the processing unit for these kind of information. An ideal scenario is that we can connect it by Bluetooth, and that's what we would probably aim for in the first scope. So the power consumption that I quoted includes all of this in it. And as Jörg said, it depends heavily on the use case. But what I showed you, the power consumption, is for 100% brightness. And that's not a typical use case. Typical use case is like 30% pixels on, and you wouldn't use it all the time. You would have sleep modes and so on. So that increases the lifetime tremendously.
Great.
Interesting. Yeah, so maybe I'm going to check the chat if there are any questions popping up. Sorry. Nope. Okay. All right, then I've got a follow-up question, or maybe a much more broader question. I don't know who of you is gonna answer it, but how would you define your success factors in the funding a startup? What were your pain points, especially when it comes to creating hardware? We've learned from previous editions of Electronic Pulse that it's a very challenging undertaking to develop and produce hardware. So maybe elaborate a little bit on your success factors and what you think made you successful throughout the years of your startup.
Yes, so I'm more than happy to answer that. So as you say, hardware startups have certain challenges that software startups do not have. And in our particular case, and I believe this will be true for many other hardware startups as well, is I think the very beginning is very challenging, because in the beginning you basically have a couple of concepts. You might have filed a couple of patents, which was the case in our startup story. But you do not yet have working demonstrators to show that what you're promising is actually working, right? So it's a kind of chicken and egg problem. So you need to have a funding to create those prototypes. But yeah, again, it's a very challenging situation. So in our case, as I mentioned in the introduction, we were very lucky to receive some public grants from FFG, from the Austrian Research Promotion Agency, in combination with some funding from a business angel. And this was basically what helped us to create the first hardware prototypes, which then triggered additional funding when it came to more public grants and eventually then venture capital funding. But I fully agree that this very early stage is super challenging to get over that part there.
Okay, there is no specific. Thank you very much, first of all, and I'm just checking the chat. There is no specific question on that part. I just want to congratulate on a great product. It's really a sensational achievement. Keep it up. Yeah, that's some great words to hear from Sandra. Thank you very much on behalf of Aleš and Jörg. Yeah, what else? Maybe further success factors that you have been able to identify despite from this pressure of having the financing and having the idea but not a working prototype. What else would you describe as success factors for a hardware startup just like yours?
Yeah, at the core of everything we're doing is always obviously our team, right? So it's a very critical thing to get the right team members on board, and luckily with the environment in Vienna and TU Wien, and a lot of our team members have a TU Wien background. This is also obviously another key success factor to get the right people on board to solve those very challenging issues and those very challenging problems. And other than that, success factors, I would say something that is very critical for any kind of hardware startup is IP. It's also somehow related then to funding, because you need to secure certain IP in crucial areas to enable not only funding but also to bring your products to the market eventually. So I would say this is also something that is prerequisite when it comes to hardware startups, at least in our experience. So yeah, other than that, I think that the location here in Vienna is great for a hardware startup, not only from all the talent pool we have here from TU Wien, etc., but also I think the ecosystem is especially also in the AR field. It's starting to grow more and more also in Austria. So yeah, I think that's some of the key success factors, I would say, when it comes to creating
Right.
a hardware startup.
Great, thank you very much. Are there any more questions? If not, yeah, we
I
can.
think there was one more question.
In the chat?
Yes.
Okay, can you see it?
Yeah. So again, another question for Sandra. How did you get your suppliers? Did you use special matchmaking platforms, or was it through research or recommendations? I would let Jörg answer it.
Yeah, so in our case, it's more research and recommendations. It's more the latter part here. And as also mentioned in the introduction, we do have a very experienced COO on board, who is very experienced in high volume manufacturing, and he's also taking care about the whole supply chain for building our products in high volume. But in the end, yeah, it's mostly research and recommendations, I would say. Yeah.
Okay, great. So thank you very much. If there are no more questions, I encourage you to contact us, contact TriLite if you want to follow up with them. I'm going to join Sandra with her words when saying that it is an sensational achievement, and you guys should keep it up. It's very interesting to see such, not really, you're not any hidden champion. You are already a champion in the Austrian startup ecosystem. So we are very lucky to have had you here. So it's very insightful. Thank you very much, Adash and Jörg, for taking your time today, not only in Central European time, but also West Coast America time. So big thank you to our partnering networks, Sandra Stromberger with Industry Meets Makers, AWS, Fachhochschule Technikum Wien, and many others. To all our viewers, thank you very much for joining in today on this occasion of Electronic Pulse. We are going to provide this video recording for you guys online at industrymeetsmakers.com. And yeah, keep an eye open for further Electronic Pulse sessions. And we are looking forward having you, seeing you, hopefully face to face in the future. And thanks again to you two. I think we're going to have a wine at the Vienna Up home base right outside at Karlsplatz. So thanks for joining. Thanks for tuning in. Goodbye, everybody.
Thank you so much.